Now we've looked at position vectors, components of vectors, and our Cartesian form of a vector. Now let's look at the polar form of the vector. Now polar form includes magnitude or the size of the vector and also the direction of the vector. So if we go back to my example, you can see we have vector u, the coordinate is 6, 4. That's the ordered pair for it. We also already investigated that the x, the direction in terms of the x-axis is 6i, direction in terms of the y-axis is 4j, and our Cartesian form is therefore 6i plus 4j. Now to do polar form, we need to know what the length of the vector is, the size of the vector, the magnitude of the vector. We also need to know the direction of the vector. So this theta here. Now that theta is always the angle the vector makes with the I direction, and it's measured anti-clockwise. And I've written that down here for a reminder. Now if you are in another quadrant, that needs to be adjusted if you're in the second and to fourth quadrants, for example. So watch the next video on that to become updated with the unit circle. You might also want to go back and watch the more detailed video on the unit circle. So let's go back. How do we work out magnitude? Well, our right angle is here, so that means our opposite is opposite the angle, our hypotenuse is opposite the right angle, so adjacent is the other side. In regards to the information we have opposite and we have adjacent, so we're going to be using tan. So that's for our direction. In regards to the magnitude, we can use Pythagoras, which is c squared equals a squared plus b squared, or c equals the square root of a squared plus b squared. So in regards to our r, which is our resultant, which we will often see, that's also the magnitude of u is going to be the square root of 6 squared plus 4 squared, the length of x, the length of y, the length of the adjacent side, the length of the opposite side, which is the square root of 52, and changing that into a surd, so it's in exact form, it's 2 root 13. And the reason for that, if you have forgotten our exact form, we can write the square root of 52 as the square root of 4 times by the square root of 13. Square root of 4 is 2, so we have 2 root 13. We could also work out, going to our calculator, that it's approximately 7.21 units. Now direction, tan theta is opposite over adjacent, or y over x. So tan theta is going to be 4 over 6, and our theta is inverse tan 4 over 6. Going to our calculators, that is approximately, I should have an approximate symbol there, 33.69 degrees. So now we have more information about this vector. We have the Cartesian form, which is 6i plus 4j. We have the magnitude, which is 2 root 13 units. We have the direction, which is 33.69 degrees. So we can express it in polar form, which is in terms of r being our resultant and theta being our direction. So 2 root 13, comma, 33.69 degrees, and again I should state that that's approximate. So Cartesian form, xi plus yj magnitude is a square root of x squared plus y squared. Our direction is going to be inverse tan of y over x, and our polar form is r comma theta. Remembering that theta is the angle it makes with the positive x-axis, or the positive I direction, and it's measured anti-clockwise.